So this is the whole repository. Let's start in the first folder. From here, the code is just in this Python script. So what do? If we don't use a graphic user interface for Python, we can just use the terminal. And then we started in this path. I'm gonna, for the first time, I'm gonna just run everything, and then we will go step by step, applying the functions. I'm trying to explain each of them as good as I can. So to this point, df is the data frame. And as you can see, it gathers all the information for each of our buildings. It is basically the meta.csv, meta open. Here, some changes have been applied to it. Let's see how it was at the beginning. So df is the join or the two data frames appended from these two studies that we mentioned we are using for the first part of the experiments. At the beginning, we just have the plain data, and then, well, these functions, they are all used in order to categorize or code the variables. So we go from strings to numeric, basically. This is like in R, we would use factors. Here, we are using these functions with regards to the categorical variables, okay? So after all of this, we have this information. Then let's go step by step. This is the last part. We convert it to NumPy for usage in a bad way, and then already we use a kprot missing, which is a function that has been defined before. Let's see what are the arguments and the outputs of this function. So the inputs are, first of all, the dataset in a NumPy format, number of clusters that we want to divide the data on, and the indexes of the features that are categorical. Inside the function, the numerical variables are just the complementary. Then as an output, very important, we get for each of the rows of the data frame, we get a label. Let's see, I'll show you. Okay, as many as the data frame where length was. See that? Then the centroids are just for each of these labels. So there are like 15 centroids, as you can see. We have computed for each of the features what is its value on the centroids. Okay, so there are like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 features, because in the data set there were 11 features. In our case, the centroids are not real, are real values. Sorry, normally the centroids don't have to be real values in the data set. So they are just like averages from each feature is an average of all the buildings that are contained on it. So that's why we will have to find the building that is closer to the centroid in the future. Then what else? We have x hat. X hat, it is just the data frame, same data frame, but with the values that were missing imputed. The imputation of the values is something internal of the kprototypes method. And I hope to explain it better in a moment. And the gamma, it's just the cost, it's the result of the cost function. So let's go. We will go on detail through the kprot algorithm, but let's skip a little bit further to finish just the iteration, and then I can explain in detail the function. So as you can remember, X hat, it is the data set with the values imputed. Then we create just like xnum and xcat by splitting the data set by the numerical and categorical variables. As you can see, these are the 4 numerical features, and these are the rest, which were categorical. We are computing here, well, we are selecting the Euclidean dissimilarity for the numeric dissimilarity and the matching dissimilarity for the categorical variables. And then here we just once more indicate which are the indexes for each of them. Then we select the one, two, three, four, five, six. We just select, I think, the features of the categorical features for each of the centroids. Okay, this was a mistake. This has to be, this is commented. So this doesn't make any sense. But now what we will do is using this function that is also defined previously, we will compute the distances between the buildings, so between the each of the rows and the centroids, using the dissimilarity, the Euclidean and matching dissimilarity, like a combination of them. Okay. So we will have as many distances as buildings. Okay. Now we have converted the data frame to DF2 for the sake of organization. X hat 2 it is everything already, like, yeah, everything in the format of a data frame, but now values are inputted. Then the labels and the distances to the centroid for in the future selecting the most representative ones. So this is the first building. It has this distance to the centroid, and the label is 12, and so forth. As you can see, 514 buildings. And finally, we also create a data frame with the centroids. Oh, sorry. And we store all this information on CSV files, which are the ones that you can see in the folder. Okay. Well, let's dig a little bit on the functions. 2 main functions we're using here are the kprot missing and the label costs too. So what does kprot missing consist of? We are going to do some debugging for explaining. I'm gonna name the variables, the arguments as they are in the input. And clusters is the same. This is just for, I will delete this. This is for debugging. Cat index is cat index. And max iter, we chose 1,000. Okay, just cut it. And right. And clusters, well, let's just, since this argument has the same name in the function and in the input, I think it's correct to do this. Okay, so my X is just the data frame, again, having the missing values. First, we identify the missing ones. Okay. Then we calculate the mean, not counting the mean values, not counting the non-available, and the modes, because we're going to use the mean for the numerical and the modes for the categorical. Now, here there are some min index reshaping functions. Here, since as an input we just gave the cat index, as you can see, then we compute the num index as the complementary of all of them. And then the filling is going to be mu. Let's see. Mu is the mean. We will start by filling. Well, first we fill everything. All right. Filling. We say this is going to be the filling, but then for the categorical features, we use a mode. Okay. Now I see there are some changes for the categorical ones. And now for start, where they were missing values, we use the filling. So before we had this X, and now we have this X hat, which for the numbers we knew, they keep the same, 2, 2, 1. But for the ones we didn't, they just filled it with the mean and the mode. Then we use the K-prototypes algorithm, which is well known, and hopefully I don't need to explain. And then we start running we start fitting for as many iterations as possible. So what do we do? First iteration, let's say, okay, max iter is going to be 1,000. Yes. So let's call it equals 0 for start. Then do a fit. These are the initial labels. Initial centroids. It separates the numerical and the categorical ones. This is important. Because as an output of the prototypes model, we get them separated. We join them. and we fill it with the right numbers. Then the missing values, which are stored in this previous variable, will be substituted by the value of the centroid, of the current centroid. So if first x hat looked like this, now x hat looks as follows. There are certain differences, as you can see, for the missing, just for the missing values. Then we do this iteratively, and then we have our K prototypes for missing values. The idea, it is the same as in the past. K-means is used for missing value data, but for a new algorithm where you have to separate between categorical and numerical values. Okay, now this was one of the main functions, kprot missing. Now labels cost. So let's see, it's this one. I think probably all of them have a name the same as in here. I'll just redo everything because of the debugging to not to make some big mistake till here. Then let's see what this labels / labels cost does. It's written here, calculate labels and cost function given a matrix of points and a list of centroids for the K prototypes algorithm. There are 514 buildings. Total cost is going to be for now empty. Well, this is just a random number, random numbers, a way to initialize it. Let's start by 0. Then I'm using the dissimilarity, the numeric dissimilarity with the numeric index, and the categorical dissimilarity with the categorical data. Okay, this is really none for the moment. And then the total cost for this iteration, it's just the numerical cost plus gamma, which is a value that is passed to the function, times the categorical cost. This is something we did not invent. We did not create it. We used some references in the literature. And that is how this first script works. Basically, you have to get the idea that out of a data frame of metadata for several subjects, in this case buildings, we are able to find their label, to cluster them independently of on the missing value that they will present. And then we also compute the distance to the centroid of their cluster in order to, in other further step, find what is the closest to the centroid and therefore the representative of the centroid. Thank you.